For designing a modern data architecture. Access to that data is then decentralized. For designing a modern data architecture. For designing a modern data architecture.
Welcome to Data Mesh Book Club, brought to you by Amazon and Starburst. Today, we're going to cover part 2 of our third book. This is Fundamentals of Data Engineering, written by Joe Reese and Matt Housley. Of course, as always, before we get into the details, I want to give everyone an opportunity to join our LinkedIn group. This is where we mostly discuss the show offline. If we're lucky, and we haven't done it yet, so I'm not going to make that promise, we're able to kind of catch some of the live conversations, but mostly this is about offline post-show conversation. So we hope you'll join us. We hope that you'll continue the conversation. Mr. Mott, welcome to the show.
Thank you, Adrian. It's good to be here again.
Hey, before we get into it, just a couple of points. This was a big, part 2 was a long section, 200 pages, give or take. I will tell you, and you ended the last session by talking about how you're kind of like, we're waiting for a little more. There's a lot in this section. I really thoroughly enjoyed it. I'll be honest, I went ahead and finished the book. I read the appendix. There's 2 appendix sections. I haven't read the index, right? I had a lot of fun reading the book, and it's a long book. I hate to read, but I didn't have a problem reading this one. But I wanted to kind of, as I sat back and had my little sipping on my tequila after I finished the book, I was thinking, I said, this is an engineering book. And what's your background, Andy? I know you have an MBA. What was your first degree?
My first degree was in chemistry. My second degree was in computer science, and my third degree is the
chemistry.
Is the MBA.
Oh, okay. Well, 3 degrees. Well, I got the first degree I got was engineering. I only needed to get 1 degree because I did the first one right. But I understand sometimes you got to go back.
Yeah.
No, well, I see that because I sat back and I was thinking about engineering in general, and there's no way I would take 4 and it took 6 years because I enjoyed college so much, but there's no way I would squeeze all of that time, all my engineering time, into a 400-page book, right? And I don't think that's what the authors are trying to do here. I do think that they're trying to give, and this is a really important point, and I want people to quote them somewhere in the book. I think it's in the last chapter, and then we'll talk about it in the next session. He's talking about kind of their position. They were trying to kind of cover the past, the present, and the trends. And so they try to kind of give everybody a broad context for where we were, where we are, and not the future, I think what I mean by the future is I think some people might read this book with an expectation that they're going to get an idea of what the perfect design is going to be. They're going to read this book and they're going to get an idea for what the perfect data architecture is going to be. But that's not this book. In engineering, where it's about designing to requirements, right? And I love what they've done with the book because that's the scope, right? And in this section in particular, they don't just talk about the content. Every chapter also says, and here is who you have to talk to, right? This is who you're going to have to work with. And then it says, and it brings back the undercurrents in every chapter. So I think they've done a really good job as we get through the idea of generation and storage and transformation and serving, of covering all of the aspects that an engineer has to talk about or think about, not just the technology, but all the other elements.
Yep. Yep. No, I'd wholeheartedly agree with that. I mean, yeah, you're right. They took through the stakeholders and the undercurrents that we talked a bit about yesterday.
When we think about data mesh, this is the way that I'm now thinking about data mesh and this data engineering book. I think data mesh as a CDO or a data leader, data mesh is the blueprint that I put forth, the strategy, if you will, that I hand to my data engineer. And I say, Mr. Engineer, and knowing everything you know now, hopefully you've done more than just read the book. I want you to design, refine, and implement this mesh, right? I'm going to hand the data mesh as a blueprint that the data engineer can then find a way to execute in the right way for that particular business. I think that's the way these two go together. Awesome. You ready?
Yes.
Let's jump into it.
Yeah.
Because this is a long section and I worry that we're not going to have enough time. We're going to do our best to stick to the hour. Chapter 5. We start with the generation. And so just to kind of remind everybody, and we'll start every chapter with this image. I think it's a good image to keep coming back to. This is the far left of the page, if you will, the far left of the data engineering lifecycle, thinking about those source systems. Now, you and I know, having read the book, the authors go into great detail into every one of these, and it's great reading, right? There's a lot that I learned, right? And I would suspect even anyone that's been doing data architecture for any number of years, there's still a tremendous amount of information here. So you can tell they've done a lot of research to pull all this information together. So again, with the data mesh lens on, right? If I'm creating that data mesh blueprint and I'm thinking about ultimately the source systems and how data is going to be produced and then how it's going to be stored in the system. I wanted to ask the first open question. Happy for you to ask any others, Andy, that you could think of. But when I start thinking about a data mesh, I don't think there's. Well, let me pause. What do you think? Is everything on this page, every one of these source systems and every one of these production approaches, if you will, would you see all of these or any of these or none of these in a data mesh?
So I think you could see any of these, and maybe sometimes numerous of these in a mesh, right? So you may have some applications that store their data and make their data available via an API, or let's say a website may store the backend data, behavioral data of individuals or sessions as log files. We may have straightforward SQL databases that are kind of storing state, I don't know, someone's bank balance, whatever it might be. So I think we will. However, I think that when we are thinking about domains, domains will want to have access to a subset of these, and to some degree, I would argue, own the kind of relationship with these with these source systems. And however. There's a bit of a soapbox here, and I'll mention this now, but I think this is probably relevant throughout this kind of whole session today. I think what we want to do is we want our domains to focus on data and basically the business, right? So what I mean by that is we want marketing people to focus on what they know best, which is marketing. The process of doing marketing well. The people in marketing need to understand and will understand data, the data that's useful for supporting that marketing activity. What I don't think they necessarily need to know is that the customer behavior data from the website is stored in a log file, or that they're accessing some data that lives that resides on some system that we have to access over an API. Someone has to hook that up. I don't think they need to know or care that they're using a SQL to access a database. And I think this is really important, because I just think, Zhamak talks about cognitive load. I think about these three areas: data literacy, business literacy, and technology literacy. I think that's just too much. And echoes Zhamak's view on that. I think we have to take technology literacy out of the domains. And so I think a domain may, as I said before, access many or all of these, but actually we should be abstracting, and in my opinion anyway, abstracting away that technology complexity and just giving them an endpoint which allows them to access all of those systems, be they on-prem, in the cloud, whatever, without having to know the technical detail of them. So I think they're relevant, but I don't think they're relevant in a domain. I think they sort of sit in that self-service infrastructure platform.
Yeah, I agree. I think everything here is, and said differently, we would say the reason why the data mesh concept exists is because of this complexity, right? And there's some pictures that the authors put together. We'll kind of come to in the next slides and start to show how this comes together, especially when we talk about storage. And they're great pictures. I love them because they're simple, but they're almost too simple in the sense that when if I'm a CDO or somebody reading this, I'm thinking, okay, I get it. No, there's a lot of lines here. That's why I have my glasses on today. But when you expand this and start to actually think about this in terms of infrastructure, it's a mess, right? There is a lot to deal with. This is why the data mesh exists, is to try to find a way to bring all that back-end data that's being produced into the right source systems. And then we've made decisions over the years as to where we're going to put data, whether those are good decisions, whether those are bad decisions, whether they're reversible. Who knows? And oftentimes they're not reversible, at least not without some cost and disruption. So data mesh comes in and says, hold on, stop moving, stop trying to change everything every year. Let's try to leverage that data where it is. And so it's this complexity, I think, that drives that principle. And here's we again, I don't go to this section in every one of the chapters, but I thought it was important for this first one to at least think a little bit about who you work with. And what I found interesting about this picture, first and foremost, I think it's spot on, right? You've got, and if you look at the bottom, so there's some text there at the bottom, I think, that I put there that talks about the data contract. Is that where I put it? No, sorry, it's at the top, right? So I love the way they define data contract. First of all, I think that's what I would expect to see. I've seen many definitions online. This is the one that I recognize as a data governance leader or a CDO. But here's what I would say, Andy. The data engineer is building these kinds of data contracts or these agreements with data owners and system owners on the back end. I've lived that. I would take it a step further and say that data engineer is also building, I would add something to the right of this picture and say that data engineer is also building a similar contract with the teams they're serving. And they talk a little bit about that in the serving section, but I want to call it out. It's not just the contracts on the back end. On the back end, you're holding your system owners and your data owners to a level. And on the front end, you are going to be held to a level, whether that's an SLA or something similar, to make sure that what you're serving is actually being delivered in the right way. To me, that sounds a lot like what we do with domain owners. That's exactly what I would want to do with a domain owner. Let me pause and get your thoughts, Andy.
So that's an interesting concept. So that's an interesting thought. So I do agree. I think
when Andy says it's interesting, it means he may not agree. He's just trying to. It's the English politeness. Now, okay, it's interesting, but interesting. So I guess maybe there's a phone call or a session that we do later on data contracts, because I think it's a really big subject. Putting that to one side, I broadly agree with what you said about the fact that you're going to have the data contracts on both sides of the domain. But actually, I don't think it's on the domain. I think it's at the data product. So I think it's the data product owner that probably is responsible for writing or defining, let's say, the contracts. But then it's
probably the data product developer who is responsible for actually implementing them. And that's my first pass, but actually I can see a situation as I speak where probably you want to delegate that down to the data engineer, essentially who becomes the data product developer in a data mesh. I do think data contracts are really important here. Yeah. And as I said, how we define what a data contract is in more detail is probably a discussion for another day.
Yeah, no, it's and you're right. We need to have that conversation just to bring the 2 points together. I'm with you on the data product point. What I've seen in practice is, so there's no right or wrong. It's what works for you, right? When you start to create these SLA type environments you don't need them for all your data products. And some you will, some you will not. But where you think you need this formal contract or agreement for a data product, which I think what you'll find, if you're fortunate, is that you can create some efficiency if you create that model for everything in the domain. In this domain, this is how we're going to operate. This is the level of federated governance or governance that we require. And every one of these data products is going to have this type of SLA or this type of contract. And then you can hold your data product owners to the same guidelines. And then a different domain may not have the same requirements. But I like being able to establish at least that expectation at the domain level, and then accepting that every data product might vary just a little bit, but within the domain, again, I would hope that we can more or less follow the same guidelines just for that efficiency. Yeah. So anyway, we'll talk about that point for 10 minutes. I'm going to walk away before we do that.
Sorry.
Let's talk about storage. Yes. And this is another really good chapter. I just kind of show the picture real quick. So we're talking about that kind of that layer that kind of works across ingestion, transformation, and serving. There was a lot of great. I'm not sure if this was the longest chapter. It might have been, but I'm not sure I've seen another book or document that put this much together on, again, from a very detailed level, bits and bytes, all the way up to the abstraction layer. I think this is a really, really good chapter. This chapter by itself is probably worth the price of the book. So I don't know necessarily that I took notes that this is information that I'm going to reuse in my day-to-day life, because it's not something that I work in on a detail level. But it was incredibly useful for me to understand the bigger picture. And at the same time, when I got done reading it, I said, thank God I don't have to deal at some of this level of detail, because I want that abstraction. I'm glad that I understand it better now, but I need that abstraction, right? I can't have my consumers having to worry about all these layers.
So yeah, I think that's true. I think it's an interesting point. I think as a data product developer, I can see situations where you may, for legacy reasons, you may have to consider different storage systems, not raw ingredients, right? I think it's useful to know, but I think the reality, and this is in my opinion, the reality of a data engineer kind of saying, actually, do you know what? We're going to store a load of data in kind of SSDs. Maybe they will. I think it's more likely that they'll go, do you know what? We'll be up at one level. We'll be at the storage system level. We might even be up at the like the data lake or the the data platform level. And the reason I say that is because when organizations are thinking about adopting a data mesh approach, it's likely they're already going to have a data platform, that kind of they have to use because it's there. And it may be that they want to change, but that change is going to take some time. So I think in the most cases, when we're thinking about data mesh, data engineers are going to be focused on that sort of storage abstraction layer. I think, you may get down into the object stores where people say, actually, we would like to, let's say, materialize our data products as maybe in materialized reuse or whatever. We need to materialize them somewhere. I'm going to use an object store. I'm going to use a cloud-based object store because it's cheap and whatever, and it gives me good enough performance. Where there might be a bit of a discussion about the raw ingredients, and I'm going back on myself a little bit, is if we start getting to the laws of physics, right? So if I've tuned everything and configured everything in terms of putting my data maybe in an object store, and I've tuned the query, and I've tuned my my computational nodes, my layers, and still I cannot get to that that millisecond, and I'm being obtuse there, maybe 1 second SLA for whatever size query, then maybe at that point your data engineer needs to start maybe looking at SSDs or in-memory sort of caching or whatever. But for the most part, I think we're going to end up at that storage abstraction from a data engineer, sorry, from a data product developer in a data mesh world.
Yeah.
So.
It wasn't that long ago. I was just kind of, as you were talking, I'm thinking, like 10 years ago, I think from an infrastructure perspective, we're building an infrastructure. We were still thinking about a lot of these components, right? We would order blades, or even before ordering blades for the data center, you would order, just, old servers, and you would think about what kind of hard drive you were going to put in there. You would think about, the kind of memory and how much memory you need. All these things were questions we asked. And then over the lifetime of that device, you were having to kind of continuously update it and maintain it. I can't remember when we stopped doing that. I know some of us are still doing that, but because of cloud technologies, a lot of that old thinking is we don't have those choices anymore oftentimes, right? It's what I don't care. I don't know. But I bring that example because that's made it so much simpler for infrastructure architects or infrastructure engineers. We don't have to worry about those pieces. We just order what's available in the cloud. It's always maintained. That's simplified. If you're in the cloud, that simplified your life a lot more. That abstraction has made it easier to focus on bigger problems. I think it's that same kind of abstraction we're looking for data analysts and data scientists. I don't want you to worry about the pieces. I want you to focus on the next step, so to speak, which takes us into kind of these big ideas and trends. I wanted to include this section I know that I had to be really picky because we don't have a lot of time and there's a lot of content, but I really liked this section. I think, and I'm not sure I'm asking the right question. Now that I read the question, I'm wondering there's probably a better question I could have asked, but I think there's a lot to think about here when you start thinking about your ecosystem, your broader ecosystem for your data mesh and how everything fits together, so to speak. And data catalog obviously was, it's something I think it probably deserved more information because it's such an important element and I think in data engineering and data architecture overall. But does everything here fit into the operational plane, right? Are these trends, are these all operational?
So really
think of the data mesh lens, operational trend versus analytical plane.
Yeah, that's a really interesting question, actually. I didn't think about it this way around, but I would say, you probably want a data catalog to work across both, your systems in your operational and your analytical. And I think there's a lot of value and merit in doing so. Data sharing, I would argue, is very much in the analytic plane. You probably don't want to be sharing data, which and by sharing is also data sharing is also an interesting term, right? Because it could be an internal data sharing or it could be external across multiple organizations. And so you probably don't want to do that across your operational plane. You probably only want data sharing in your analytical. The schema one, I'm not really sure kind of how that fits. I'm going to jump over that one for the time being. But then, the separation of compute and storage, I would argue mostly in the analytical. Single tenant versus multi-tenant storage is to me is where we start getting into probably analytical only. So I think the more I look at this list, I think it's probably the catalog is probably the one that spans both. And then the others, I would suggest, are probably more focused on just in the analytical plane as kind of concerns or trends or things that impact or influence the analytical plane. But I do think the catalog should go across both, and I hadn't really thought about that before. So it's an interesting question.
Well, the way they discuss catalog in the book is largely the more of a technical catalog, but I think most of us thinking through this, when we think about catalog, we appreciate the back end technical catalog as the meta store, if you will, as much as we appreciate the front end catalog where you might have something like data products. But I asked that question because I do think my initial response, storage, it's back office, right? And then it's like, well, hold on a second. I think the trend now is we do want to abstract technology. Yes, absolutely. But there's some capabilities like a front end catalog, like enabling your teams to empowering them to do some of their own compute, if you will, that I think start to kind of bleed into, is that the right way to say it, kind of move forward into the analytical plane because you're empowering teams to do more on their own. Not everything, but some of those pieces. Yeah.
Yeah.
Ingestion. Awesome. Speaking of ingestion, Andy, what did you have for dinner last night? What was your favorite? What's your favorite? Because I know you're coming to Boston next week, and I hope you'll
Yes.
kind of get some good Boston food.
I've got to find some, of course. I've got to, is there good food in America?
Oh, indeed. I mean, there's got to be more than fish and chips and Indian food, I think, right? That's all you eat in London.
Whoa, don't be rude about English food.
Okay.
uh,
Not digestion, ingestion, right?
Indigestion, I think. Yeah. Anyway, yes, let's get on to ingestion.
Yeah. So
Yeah, sorry.
go ahead, Andy.
No, after you.
All right, fantastic. So again, I like to come back to the picture to kind of show where we are again. Now in the book, they start to cover now the 3 boxes across the top where we've discussed generation, we've discussed storage, and now we're going to cut across those 3 big elements: ingestion, transformation, and serving. But first, we start with the ingestion piece. I'll be honest, I had a hard time trying to figure out which parts of this chapter I wanted to bring forward, and I got too deep. And I took a step back and I decided this was a good list to come from, right? The consideration side for 2 reasons. I think one is it's a great list. I think it's a great conversation for us to just walk through these with a data product lens and a domain lens, right? So one thing where they're largely talking about ingesting into a bigger system, or thinking about, ingesting into a bigger platform, or ingesting into a storage environment or something, so you can do the ETL. But when I read this list, because we're data mesh guys, I'm thinking about how I ingest into a domain, and the conversations I've had with teams about when we start to kind of create domains. And ingest might be the wrong word, because I'm trying not to necessarily physically move data so as much as I'm trying to make that data available. But I think I ask myself that same types of question. If I'm meeting with a domain team, it's okay, so what's the use case for the data that you're going to need? And then how often are you going to reuse this data within this domain? What other domains might want to reuse this data? And then how is the data going to be used? Where is it going? So if we make this data available to the domain, are you using it for dashboards? Or are you using it for ML engines? Or are you using it for applications? And how much data are we talking about, right? I need to make sure. And so I thought it was a very useful list. If you're having domain design conversations, I thought it was a really useful list. I just want to make sure that we're clear on the idea of actually ingestion or moving data, versus sometimes when you think about a logical domain, you're not actually moving a whole bunch. Hopefully you're not moving a whole bunch of data into some physical thing you call a domain, as much as you're just making that data available to them, maybe via query. So that's what I got out of this list when I read through it. I said, that's a fantastic way to think about how you are going to make data available.
Yeah, so there's quite a bit to this, I think, when we think about data mesh, because as you said, making data available isn't necessarily the same as ingesting data. You can make the data available without ingesting data, and it may be that you make the data available, you build a data product, and then you decide for whatever reason, maybe you've got a concern about running a query against operational system. Maybe you do stage or materialize that data in a second system, or in the analytical plane, I guess. The concern that kind of raises its head quite quickly when we start ingesting data, in my opinion, in data mesh world, is you end up kind of with basically very specialized skills, right? So if I'm moving data from one place to another, I need to know the operational system. I need to know kind of the data model in there. I need to think about the technology that I'm going to use, and the book does a great job of detailing streams and CDC and batch and messages, etc. And I also then need to understand that analytical plane where I'm going to ingest the data to. And when I go back to the concept of a marketing domain, do we really want to require our marketing function to kind of require all that knowledge, as well as the business literacy and the data literacy? And that's where I start thinking, what the danger or the slippery slope is. Well, that's hard. So why don't we get some skills that can do that? Maybe why don't we get some skills that can do that across maybe domains, and maybe we put those into a team. We get back to a central data team quite quickly. So So I think that's one thing that I'm always kind of very conscious of is when we talk about data ingestion, it feels like we're getting down to that back to a central data team potentially quite quickly. Not always, but that's a concern. I do agree with your comment about the kind of the key considerations on ingestion. How often is the data actually updated in the underlying system? Is as important, in my opinion, as how often can we make a decision, right? So it might be well and good to build a funky streaming mechanism, which is getting the data at every second and ingesting it into a system and putting it there. But if I can only make a decision once a day, or if I make a decision and the action can only be taken once a day, it doesn't really matter, does it? It doesn't, I've kind of over-engineered at the front end. So I think that's as important, and I think you kind of mentioned this. I think that's as important as the action that you can take on the decision that you're making based on the data. The timeliness or the periodicity of that is probably as important, if not more important, than all the other considerations.
Yep.
That will be.
And I want to be clear on this, because I don't want someone to misunderstand. I get what the authors are describing when they talk about ingestion, and I certainly appreciate that in any organization, probably every organization, you're doing this kind of ingestion. It makes sense. There are good reasons to do it. I am challenging, and I'm saying, hold on a second. When you start thinking about the way that you create that blueprint for your data mesh, you start thinking about domain design. I want you to rethink the way that ingestion works, because when you're having I think what is one of the bullets towards the end, I can't count how many are there. My glasses aren't good enough, but when you start thinking about having to worry about the format of the data you're pulling from and the format that you're trying to feed into, and that's time and that's money, right? When you think about ingestion more from a virtual perspective and saying maybe I'm using Trino to bring that data forward, it makes it much simpler. It makes a lot of these concerns, you still need to think about them, but they're much easier to work around. So I just want to challenge ingestion and say there are different ways to do it. And sometimes when you're building a mesh, moving all the data into one spot is not what we're trying to do. We're trying to leverage data where it sits. Fantastic. Yeah. We get into batch ingestion considerations. I don't know necessarily if this is something that I necessarily find extremely relevant to data mesh. Other than to say that you're going to have good reasons to do kind of streaming, maybe active ingestions versus, a nightly batch ingestion. I know we see that all the time. I don't know. Is there anything here that we would think this makes a data mesh approach easier or harder? I don't know. I think it's just a capability you leverage when you need to.
Yeah, I don't think this. These are all valid approaches to moving data around, right?
Yeah.
I don't think that I don't think data mesh is opinionated on any of these, to be brutally honest.
The only thing I would say, and kind of linking back to what we just said, is again think about whether you really need to move that data, right? That's the challenge. Is I'm challenging whether or not you need to move it. Otherwise, if you do, every one of these methods is probably a good approach. All right. Now we get into the ways to ingest data. And again, this was extremely useful. And these are not, there's a long list. All I've done with that long list is I put them side by side, but these are all peers, if you will. Everything here is on the same level. A lot of information, obviously for time reasons, we don't have an opportunity to go into any one of them. I asked this question because as I got through this, and again, I found it extremely useful. I sat back and I said, so what's the right one to do, right? If I have to move data around, or maybe if I'm querying data, if I'm building obviously most of us don't have a choice. We're dealing with what we have in place already, but if I'm in a greenfield environment, what am I doing? What's the best thing to do? And I'm going to call the obvious one out because everybody's in love with APIs. Although when you get to have too many, it's hard to manage, believe me. But it works really well, right? As long as they don't break them on the front end. But taking APIs off this list, right? What else? If you're building a greenfield environment, is there anything you're staying away from or anything you're sticking to, Andy?
So I'm gonna avoid that question by saying data lineage. Just data lineage, right? Because if I'm moving data from place to place, I want to be able to represent that, as a graph or whatever. to an end consumer so that they can understand where that data came from, what things were done to it on the way. And we'll get onto that in the transformation piece. But I want to have some visibility of kind of where that data's come from and kind of broadly what's happened to it. And I look at these, and some of them I think they fit really nicely with the story about data lineage, right? You kind of call outs at different points that kind of say, oh, I've done this, and this much data's moved to here, and but I look at this and I think if I'm SFTPing, then that's probably even in a sort of scripted way, batched up or whatever. We're probably going to that because we don't have a better way. We don't, for whatever reason, we can't do APIs or we can't do change data capture. So I look at some of these and I think this is a long list. And I think we may need to, we may need to use some of these, but I don't, I think there's probably a priority here, and it's probably, CDC, event streaming, APIs. Maybe the managed data connectors are probably, the ones that we should look at first. And then we start looking at the other ones. If we don't have access for whatever reason, maybe these are legacy systems, or, maybe the data's coming to us in a weird way from an external source, then I think we end up going down the SSH or the SFTP route or whatever. So I do think there's some prioritization here. And I come back to the reason I say that is simply that the ones that I sort of mentioned first are probably easier to manage and monitor and get that view, rather than if I'm scripting something, I've got to write out logs. It becomes the responsibility of the data product developer, I guess, to kind of get into what I would sort of suggest is more infrastructure. Sort of sending notifications out to something to say, this much data's arrived, this much data's arrived, this data hasn't arrived, or whatever it is. Does that kind of make sense?
Yeah, no, I do. And your expertise here is certainly beyond mine. My simple observation to kind of close up this page is I think the reality is it's hard to get data, right? Number one, and why do we need this many different ways? It's hard to get data. Web scraping, are we still doing that? Yeah, some of us. So I think that's the first challenge, is trying to capture so many different types of data sets that are out there, unstructured data in particular. I think you've got to be creative sometimes in how you do it. You capture it, and then the second question is, where am I going to put it so that it's easily accessible, right? By the way, SFTP, TFTP was my favorite thing in the world when I was a hacker.
TFTP. What is the T?
Well, I don't even remember anymore, but it was TFTP space Etsy password, and I could basically get a password from any router or Linux system or Unix system or Solaris or whatever. And so that was my secret hack, right? Nobody would actually change it. Anyway, there you go. And now it's secure file transfer protocol. All right, we move on. A little bit of history there. All right, chapter 8, the queries, the modeling. So now we're getting into transformation, right? So now we've talked about the ingestion, and the last thing I said there, you do what you have to do to kind of get the data forward. Once you get it forward, now you got to do something with it, right? Now you've got to actually transform it. And so we're in this kind of middle transformation phase, which is the trickiest phase. I think I feel like in part 1, they talked about this kind of being, I'm not sure they said it was the most important or the most complex, but it is key for certainly analytics. You have to make the data useful to somebody that's going to use it, right? And so that's what this whole chapter is about. We talk about queries, data models, and transformation.
Yeah.
Before I go into any questions, let me just pause for a second and see if you have any ideas or thoughts on this chapter.
So so my initial thought is, everyone knows what a query is. We don't have to go into a lot of detail. I think transformation, the difference between transformation and query is essentially that when we're writing a query, the output is going to go typically to like a human, if you will, or maybe some other system. But with a transformation, the output is something that's kind of written back somewhere, right? And so you could argue that a query and a transformation are very similar. I think that's broadly the definition they use in the book, and I do agree with that. Data modeling is a really interesting area. And I would suggest that up until about 2010, data modeling was a really important kind of skill. It was really important for lots and lots of projects where, we'd have someone at the beginning of a project would go in and they'd look at, work with analysts or people in the business, and they try to model the business essentially, or at least aspects of it. So, what's a product? What attributes does a product have? What is a customer? What aspects and attributes does a customer have, and how does a customer maybe relate to an order? These sorts of things, and that we seem to have just stopped doing for whatever reason. We could get into that another time. Probably for the last decade or so, and I'm starting to see data modeling become back into vogue a little bit for various reasons. And then if I think about that from a mesh perspective, I think there's some really interesting ideas here. So, and we may go into this in one of the future slides, but back in the day, there were Kimball and there was Inman in terms of approaches for sort of data modeling. And I, some time ago, maybe a year ago, I put it on my whiteboard, the question, is a data product really a Kimball data mart? Right, and Kimball Data Mart broadly is just a way of bringing together data for a particular subject. So that could be a data, let's say it's a product. If the product that we sell, maybe it has a SKU, maybe it has a price, maybe it has some components. It has some attributes, right, that make up that product. And maybe you have a Kimball Data Mart, which is maybe a collection of tables that kind of represent those attributes and that data product in data. And if I'm thinking about a domain, maybe I have a data, I'm using the word product too much here, I realize, but maybe I have a domain which is focused on providing product data as a data product to the rest of the organization. And, is that a Kimball Data Mart? Well, possibly it is, right? Possibly it's a Kimball Data Mart. Possibly it's materialized in that way, but with maybe a view on top that gives you the right sort of view of the data. I would suggest that the data product goes beyond that, and we can talk about that. Things like ownership and tagging and policies and having that all in a self-contained thing. But I think this is where, if I look at these three items, I think this is where there's a really interesting intersection with data mesh. I think this is something that people don't really talk about yet. I expect this to become more of a thing. I have seen a blog or two which reference this Kimball data product, kind of what's the word I'm looking for? Similarity, I guess. So some people have started thinking about this, but I do think that to me is really that's kind of an interesting intersection.
It would be amazing, Andy, if somebody put these things together, right? If somebody could invent a query engine that would allow you, maybe with like a distributed query engine, imagine that, right? That would allow you to query a lot of different things concurrently. And then I'm going to say something crazy, and then actually transform that data in the right way within the query, and then deliver that to a consumer. Why doesn't somebody invent that, Andy?
Well, I know this is a Starburst sponsored event, but we do our best to be a little bit agnostic. But I think you're broadly correct, right? You can represent data, you can transform it, you can query it, and if you've got an engine that allows you to do that without having to know the technical details, that's a pretty cool thing.
Makes life a lot easier for sure.
Yeah.
Fantastic. All right, we're getting into chapter 9 now. So we're getting dirty, so to speak. We've got the data transformed, and now it's about actually serving that data specifically. And they come up with they're focused on analytics, and that's the broad term they use, machine learning, and reverse ETL. One thing we haven't challenged earlier, I don't think, and when I draw this up, and everyone draws this picture a little bit differently, but for the most part, I think we would all agree we're aligned on the big boxes. I have an applications box because sometimes I'm serving data to applications, but to be fair, and I'm not talking about analytics engines like BI tools or machine learning engines. I'm talking about applications. Maybe that box is missing, but as I read through it, I think that there are different kinds of applications, and Joe or Matt probably correct me and say, Adrian, what kind of application are you talking about? Okay, it fits there. And so I think applications probably cuts across all three.
I think I think they probably would argue that that's a type of reverse ETL. I think
Is
probably.
possibly, yeah, because the application output is going to come back into, makes sense.
However, I'm going to say reverse ETL isn't a thing. Let's just get that out there, right? That's got no place on this box. Reverse ETL is basically ETL, but the target, the thing we're loading into, is the source system. It's one of those things in the generation box, right? Otherwise, it's not a thing. And I know lots of people talk about it on LinkedIn and there's blogs and all that, and that's wonderful. Not a thing.
It's the reverse part, again, our semantics, right? It's not really going backwards. You're looping, maybe loop ETL. I don't know. Anyway, let's go. So I would be foolish if I did not at least quote what they talked about when they referred to data product. And I apologize, a lot of text. That's why I'm wearing glasses. But this is what they said about data products and data mesh. And we're not going to read through it. That wouldn't be useful for the audience. But as we start talking about how we serve data, I think, and I rightfully so, I think this is where they start breaking into the different elements that are special to us. Like, and I missed self-service, right? Self-service, data products, and data mesh, right? These are all really important. I don't think there's anything here, if you're building a data mesh, that is, I think you could almost say general considerations for serving data in a data mesh. Every one of these elements is really important, especially that first one. And if you look at the table of contents and you see trust, you're like, how does that and it's like, how does that fit in, right? It's not technology. You're right. It's not technology. And they said at the beginning of the book, this isn't all about technology. That trust piece, I think, is really important. No one's going to receive the data you're serving if they don't trust you. There was a famous quote, I can't remember if it was Gartner or Forrester that came up with it, but it was something like, 70 to 80% of executives don't trust the data they're making decisions from. So it's a key piece. But is there anything out of this, Andy, that you'd want to pull out in terms of how they think about data products and data mesh?
So, and it's not a data mesh book, right? So I'm conscious of that. But I kind of look at the diagram from left to right, and I think we've got generation through to analytics, and I kind of think that whole thing is a data product, right? That life cycle, in my opinion, happens potentially. I would argue it happens within a data product, and we can get into semantics here, but broadly,
at a micro level,
So if I was being particularly contentious, I would say data products aren't really in the serving. I think that I think when you start thinking about data products being part of the serving layer, you've probably got a centralized architecture behind you. And I think that means that that's fine. It's not a data mesh, so let's not call it that. But what you're not going to get the benefits of data mesh, right? You lose that agility. So I do. You have to put this somewhere, right? And I do get that. So this isn't necessarily a big criticism, but I guess my criticism would be, or my observation would be, that I think you could just put a box around the whole data engineering lifecycle and say, this is the data product. It's this whole thing from end to end. So that would be the big thing that I kind of, that I was sort of upset is probably too strong, but it didn't gel with me that we put it, talking about data products in the serving layer.
I'm going to run the risk of being far too out with this and maybe getting laughed at, but I would say I think we have to be really careful about not over engineering data products. What is that? And I had it in my mind and I forgot now the name of that movie. It was Tom Cruise kind of moving data around, right?
Minority Report.
Minority Report, yeah. And when that first came out, it's a long time ago. That's as an engineer, you're like, that's where I'm trying to get, right? We would use that example when we're building dashboards, 10 years ago, risk dashboards, whatever. We would say that's what we're trying to get to. Okay, so now we're here and we almost have the ability to do that with data where you can kind of bring data together. Can you imagine Tom Cruise, that part of the movie, and then somebody standing over his shoulder saying, oh, hold on a second. He gets the answer, and then somebody says, okay, hold on a second. Now we've got to go test it. Now we got to go do this. And then he has to wait for, and he's like, I already got the answer. And no, you can't do that because we got to get the data that you virtually put together. Now we have to move it over here. So it's like, what? I've already, so I that's not the way it's supposed to work, right? The way it is supposed to work is I have access to the data. I trust where the data came from. Let me do what I want with it to a degree. I get that in some domains, you're going to be very strict. You want to have rules. That makes sense. But in other domains, let people play with data, let them move it around, let them put it together, let them, if it doesn't work, do something else. That's, I think, what we're trying to get to. And I think we're so used to working the old ways, bronze, silver, gold, or whatever, kind of going through all these processes that we miss the point of why we're trying to simplify. Simplification means I can do what I want with the data to find the answer I need so that I can make a decision. Tom Cruise if somebody had over-engineered that process, the movie would have been boring because he would have had to wait 6 months for that data product that he built to finally give him the answer. That's not the way it works. Anyway, sorry, let me move on now.
That is true. Well, I guess so. I'm just so like where I'm coming from with the data product being wrapped around the whole process. That thing that Tom Cruise was doing, that to me is transformation.
Yes,
that's transformation, right? That's in the data product, right? He's building a new data product, maybe based on some other data products, but he's doing the transformation that in real time. So that's kind of like that's how I'm thinking, and I think it echoes with what you're saying, but without necessarily the old-fashioned film references that no one else will get.
Come on. All right. Like Xanadu, right? No, I'm joking. I'm not going to talk about Xanadu. All right, that's an older movie. All right, Olivia and John. I've got her poster here on the wall still. It's my favorite actress. Yeah. Okay, we are way off topic here. So analytics, machine learning, university. Now we're kind of talking about who we're serving to, right? And I think we've talked a little bit about this already. You said there's no such thing as reverse ETL. Yeah. Can't wait for the comments online about that. But to your point, I think you've already said it, right? When we think about that data lifecycle, and you said that's the same thing you would think about when you're building data products. And I balance that by saying, be careful not to over-engineer it because you should be much more agile. But at the end of the day, you're serving those data products to the same audience, right? I think it makes sense. Yeah.
Yeah.
Awesome.
Yeah.
That's it, Andy. We covered the book. And to be fair to the authors, because I don't want anyone to think that there's a lot that I didn't get into here. I mentioned before, and I'll say it again, I really like the sections that talk about who you work with, right? And every one of these chapters also has the undercurrents. So you talk about storage or transformation or ingestion, and then you think about who you work with, and then you think about the undercurrents. I like the way they framed every chapter that way because it does give you that holistic perspective. I don't think, and I said it earlier, I'll restate it, they haven't forced 4 years of engineering into 400 pages. That's not what they've done. It doesn't make you an engineer when you've read the book. When you've read the book, it gives you a broader view of everything you need to understand. It doesn't give you a blueprint for a perfect data architecture. If you want the blueprint, one great opinion out there is Jamak's data mesh book, right? But even that blueprint requires disciplined engineering, and I think this book kind of lays a foundation for what's going to be a really, really good data engineering foundation. Andy, I know this isn't the closing because we still have 20 more pages left to discuss in the next section, but I really enjoyed part 2. What were your overall thoughts?
So I'm going to echo some of the things you said, right? There's a lot of 1-2 page definitions of all kinds of things, from the way magnetic disks work, all the way to what query federation is and what graph databases are. And so I really like the fact that you can kind of, you can use the book as a reference. Certainly this chapter, you can use it as a reference and go, someone's asked me about, streaming data or bounded with a bounded context or window functions or whatever. And you can go to the book and you can get a concise definition, which has, which is kind of well written for someone with not a lot of knowledge in that space. So I think this is a really interesting, it's really valuable, very comprehensive chapter. So I think it was a good read. I think there are places where so to give you an idea, I've given this to some of the folks in my team. And I can see they're probably not going to read all of this section, right? That's the reality. But I know they're going to read some bits and they're going to get some value out of it. So I think that's the way I look at it, and I do think it's really useful actually. We didn't cover a lot, as you said. You know, there's just on the serving layer piece, we didn't talk about semantic layers and metric layers, for example. We didn't really get into the query federation piece, although, you know, Starburst.
That was a great chapter, you know, and I had some of those parts in, and I didn't think we were going to have time. And now that we probably had time to do another, I just, that's my mistake. Maybe we, you know what, Andy? Maybe we squeeze some of that into the part 3 that's coming up.
Okay. Maybe we do. So I just want to make sure the audience is aware that we have really skimmed the surface of this and just taken the bits and pieces that are, you know, kind of relevant to discuss with a data mesh lens. But yeah, it's a fun book.
Yeah, and I also want something I told myself I would do. I read the book. I know I have the paper copy, and so we both have the paper copy. But you know what I found really useful? O'Reilly has a web. You go to the O'Reilly website, and you can do a trial. You do this trial with them, and I'm going to actually subscribe to it. We have access to all their books, and somehow I find it easier to read on a big screen than it is to read in a book. And so, anyway, just credit to O'Reilly. I really found that super useful, because then you can also search for some of the terms like serialization. By the way, it's covered really well in the appendix, but I was like, I need more on this topic. You search for serial, and you have all these other books that are out there that you can access that talk about the same topic. Anyway, I just thought it was a fantastic way to show the library.
This is an index. Just saying, Adrian. This is.
I read no. I get it. Who wants to go to the index when you can type it, right? I want to do what Tom Cruise does, right? That's what I'm trying to do, right? Okay. Anyway, hey Andy, awesome show. Thank you. I can't wait to finish the book, part 3. There's only 20 pages left, but I think we're going to bring some of the part 2 pieces back in, because you're right. There's some really important, useful things that my fault. I probably should have included. So I hope everybody has a great evening or a great morning and great day. And I look forward to joining you, or hopefully you join us, Andy and myself, for part 3.
Thanks very much. Yes, bye.